Hello, hello.
Hello, Gabriel.
Hey, Steve. How you doing?
Okay.
So
Finally
what?
was able,
Podcast.
finally was able to log into the survey link thing. I added one or two things.
Yeah, appreciate that. And sorry for the delay there. Just got don't always check the OCP email just yet. Getting used to that. And
Yeah,
just your when you sent the follow up, that's when it. Oh, right. Send the invite. So thanks for following up.
Hey, Gabriel. Hey, everyone.
Hey, Virat. Good to see you,
I have
man.
a
Good to hear you.
Good to hear from you all.
How
Happy,
you doing? How you been?
pretty good. Yeah.
How's
Uh,
how's the kiddo?
fatherhood.
Fatherhood
Yeah,
is treating me well.
awesome. Good
Well,
to
be
hear.
careful with all the bugs out there. My granddaughter just caught the flu from her mom yesterday, and even though she was masked up,
Yeah.
103
Unfortunately,
fever.
yeah. So that's going around with the babies. Yeah. We gotta be better vaccinated. Yeah.
It's just gonna get worse, right?
Yeah. Getting worse.
Yeah.
But yeah, good to be back. But hey, Gabriel, I'll be there for the first 30 minutes, but I know you and
Hop
Steve,
off. Yeah, no worries.
but yeah. And I can also
Awesome.
see David on the call. Hey, David. Hey, everyone. Hello.
Hey, David. Hey, Anne, Matt.
Hello.
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 All right, let's give it one more minute, and then we'll hit it off. We'll do a little recap, um, and look at next steps. In the meantime, anyone want to introduce themselves? Zan, sorry, I don't know if I've seen you before.
Yeah. Hello. I'm Sicheng, or I go by James. I'm a postdoc at MIT. Just started a new project on data center heat reuse, and I saw the OCP stuff. I was in the general core last month and realized there's this more specific core on like the technical details. And I also saw you guys mention somewhere that you are investigating the waste heat reuse in different locations. I think like cities with different climates. So that's quite relevant. So I thought I would just call in and learn and possibly contribute a little bit. Yeah.
Beautiful. Yeah, awesome. We'll definitely. I think we'll start off with that. Steve's done some good work on more exotic applications. He's gonna help us and hopefully can get some help himself on how heat reuse can be used for other things like desalination, water treatment, etc. So I'm not sure if that's looking slightly towards what you're studying, or if you're just looking at heat reuse more generally. What's the angle?
Our project is more towards district heating and cooling.
District heating. Okay.
Yeah.
Cooling too. That's nice.
Yeah.
That could definitely be one we look at.
And did you
Awesome.
find on the website the past presentations and so forth? Have you found all those links?
Yeah.
Okay.
There's this wiki page, I guess that's what you're referring to.
Yeah, yep, exactly.
Mhm. Very useful resources.
It's good to hear. Awesome. So maybe we can just start it off. We have kind of two main things that we're looking at today. One I would say is definitely more on the technical side, with this idea of heat reuse is very frequently deployed in very cold climates, as it makes sense. District heating networks are pretty readily available in a lot of parts of Northern Europe. Um, Less so North America, but there are some examples. And then um, Steve came up with a good idea to maybe look at other kinds of applications that could be deployed elsewhere, or not so weather reliant, but more can be run around the clock, adapt more to the profile of a data center as well. So main ones, yeah, being kind of water treatment, and desalination. I think cooling is one we haven't talked about, Steve. I don't know if that would be one to mull over and try to fit into the project, or if it would be something separate. But
But
if you
district
want,
cooling, district cooling.
yeah, yeah.
No, the white paper I'm proposing is specifically more aimed towards water
Hmm.
recovery and conservation.
Great. Do you want to give
Although,
a? Yep.
yeah, go ahead.
I was just going to ask you. You want to give a quick presentation of where you've gone so far, the executive summary, kind of the contents. Maybe James can chip in and
Yeah, sure.
add some thoughts.
Let me share the first draft I put together here. I can on my cluttered desktop figure out where it is.
And
Yeah,
maybe while we're
no
waiting for
worries.
the presentation to come up, I missed the last 30 minutes of the last meeting. Was there some decisions on like pathway to take? Is there still the interviewing or
Yeah,
like projects? Is that still on the table or was it mainly
yeah. Big time. Interviewing is moving forward. I'll touch on that after you hear
okay?
from Steve.
Sounds good.
Yeah.
Okay, so basically, I started putting together the framework of a white paper, calling it Reference Designs for Data Center Heat Reuse for Freshwater Production and Facility Water Conservation. Uh, this was first driven by the idea of let's go with desalination in suitable locations, because that's essentially a 24/7 operation that is insensitive to seasonal demand and can tolerate daily fluctuations just by having a tank in which you're collecting the water you're making. And then it was said, well, let's see if we can make it more generally, towards water and overall. And so I drafted uh, an executive summary here. Can everybody read it, or do I need to make it bigger?
Looks good on my side.
Good for
All
me.
right. So basically, I tried to follow the approach and wording and stuff that we used in previous white papers. Said, roadmap for providing data center heat reuse. And really, I'm thinking of about two types of reference designs. One from, you know, a desalination approach, and the other one is provide ways of providing waterless cooling with the option to produce fresh water from impure sources, which would be more for like inland locations. And then there are, sub cases, doing it from liquid cooled IT and for two-phase cooled IT. And so, the usual objective kind of stuff of what do we want to do with reference designs and so on and so forth. Again, we're going to have to talk about business considerations. And then I think what's a little bit different this time from the general, you know, uh, reference design thing is instead of matching uh, the off-taker thing, it's really matching the freshwater production and conservation to the data center cooling demand, the variability, when we talk about seasonality and stuff
Hmm.
like that. So that's basically the executive summary. And I took a swipe at putting together some reference designs. Oh man, it got shrunk here. Okay. So the five different cases. The first one is where you've got heat reuse from liquid cooled IT, and can we use the heat directly with, let's say, a double effect or multi-effect evaporator? And the fact that you have cold seawater, that would enable it. And I've actually done some modeling and some simulations of this in Aspen Plus. I'm a chemical engineer, by the way. Then there is the variant where you can use it with two-phase cooling instead of indirect, so you get a little bit better temperature approach and efficiency. And then for inland cases, that are using evaporative cooling or cooling towers, does it make, excuse me, does it make sense to do this, put in a heat pump to try to, boost the temperature and actually just enable you to go with dry cooling I think we should probably take a look at it. I don't know if it becomes cost effective. It may be more sensible for doing that where you're dealing with air cooled IT because you know you can provide through the heat pump essentially chilling. It's essentially turning the chiller system in using it to run on dry cooling, and then variations where we got liquid cooled and
So
then
those are the examples where you're saving water by doing dry cooling.
yeah.
Okay.
So saving, you know, normally where you're using water, you know, to cool the TCS stuff, you switch it to dry cooling either directly by means of a heat pump or coupling that with, you know, as long as you're going to put it in, maybe you can also desalinate or purify local water, you know, cooling tower blowdown or
Hmm.
you know, saline aquifer water, whatever have you. And then, you know, the variants that are based on liquid cooling and the variants that are based on a two-phase cooling. So that's pretty much what I have to put together. Now, obviously, you know, oh, and I also wrote an introduction, but you know, we need to go beyond just these two pieces and fill in the rest of the parts that go into the reference design. And this is obviously not something I could do just by myself.
All
So
right.
I
Any
stop
comments,
sharing.
questions? No, keep it up there if you don't mind.
I have a few comments. First of all, great job, Steve. Herb Stein. Is 5 years from now, will there be air cooling, frankly? Should we continue to make the case when the case is pretty well closed? I mean,
I mean, I think it's pretty close to maybe in this group, but unfortunately,
well,
still
but
a
I mean,
vast majority of
we're the
engineers
leaders.
Oh,
I mean, if you're going to recapture heat for desalination or any use, is it practical to use air cooling as the base?
Well,
And
I
all
just
the
want to
well,
be clear,
infrastructure.
guys.
80% of the data centers out there are still legacy sites using air
I
cool.
get it, but you know, they said that about horses in 1900, and frankly, we
And they were
shouldn't be
still being used in
promoting.
1920s.
Pardon me?
And the horse-drawn carts were still being pulled around in the 1920s.
Not too many. I can
Not
show
too
you a
many,
picture
but
that suggests otherwise. My point simply is, as an organization of moving forward here, the leadership, we should be promoting what we think is going to happen, not history, which has been pretty unsuccessful, frankly. And I'm not. And my second comment is, and maybe you know, Steve, what is the temperature that we need to, without heat pumps, to desalinate? What does the exit temperature of the waste heat have to be?
it really comes down to the temperature difference between where you're finally doing your last stage of condensation on the evaporator. So I assumed if we have 20 degrees C or cooler seawater, we can run with 40, 45 degrees
Mhm.
heat coming in. Let me,
And we
So
might
60 C would be 60. Would you need a
oh,
heat pump
60 would
if
be
you had?
great.
Yeah, okay. That's my question.
we
Here,
might need Steve to work out a few different sea temperatures as like 20 degrees, you know.
Right.
Some
yeah.
parts of the world is, but drier parts of the world, like the Middle East, for example, they're probably looking at closer to 30
Well,
degrees.
actually, you go down a few tens of meters to you know, from your intake pipe, and your water is already fairly cold. There's a thermocline pretty much almost everywhere. But here you can see I've got, you know, from 40 degrees C, first stage evaporating at 35, second stage evaporating at 25, and you know, final cooling at 20. So I picked a 5 degree approach as being reasonable.
Mhm.
I mean,
See, if
obviously,
it's,
the bigger the delta T you have available, the smaller equipment you need for the evaporator.
so if you had 60 C, what would it look like coming out of the data center?
Well, 60, you could probably get, you know, go with air. You could probably possibly even go with air cooling with at 40 degrees C for the final stage.
Yeah.
Or you could put in additional effects and get that much more water. You can go to triple effect, quadruple effect. So, you know, essentially you're reusing the heat here just once, reusing the heat twice. So you essentially double or triple the amount of water that you can get out for a given amount of heat, kilowatts that you're throwing out.
Yeah, the reason I'm pushing this so hard is because, Frank, I used to own and operate district heating and cooling systems, and I always felt that using data center waste heat was a mismatch because of the seasonality, but also the temperatures that you have to send out.
Excuse me.
And so that's why I've been pushing so hard for something year-round and practical, like desalination and water treatment. You need something where there's a continuous load year-round. Otherwise, you have to have all the infrastructure to reject heat that you'd otherwise need, and you'd only use it part of the time.
And I cover that impact in the introduction, about
Yeah, right.
payout time and stuff like that when you have seasonality effects.
I mean, to me, matching district heating with data center waste heat is more public relations than real progress. It simply doesn't. It makes you feel good, maybe, but it doesn't really move the ball forward.
Do we have any statistics on how much energy is currently used for water treatment and how much energy could be saved that way? Because I actually have no idea. I have a rough idea how much energy is used for heating otherwise. So I know that the data center market is way smaller than the heating market, but I have no idea about water treatment.
That's
It
a good
really
point,
depends on
Annie.
Cal.
I think looking at desalination specifically, I think it would be good to understand the energy consumption and also the cost, because in places like we're working quite a bit in the Middle East these days, and so much of what goes into thinking about water is now the cost of energy. For them, it's quite cheap right now, but in the future it might go up, and they're seeing that more and more. That's the big problem, like the cost of energy for fresh water. So I think if we could figure out energy and cost, that would be fantastic.
Yeah, I besides obvious places like the Middle East, and in fact the Gulf Coast Association is taking a look seriously at integrating heat recovery with desalination. Other candidate places would be places like Portugal and Spain, where they already have water shortages and a suitable location and a demand for data centers. And where there, the energy cost is much higher than it is in the Middle East.
Mm-hmm.
Excuse me.
And that kind of goes
So
back to Herb's point, I think, and I tend to agree with Herb that um, we're talking about new construction in the future, right? We're not going to be picking up air cooled facilities and moving them to desal plants or vice versa. So it really is net new deployments, which if you're going to site it next to desal for the purposes of providing waste heat, you're just not going to do it with an air cooled facility. You're going to do liquid cooled. Um, so it might as well just look at direct to chip there, I think.
Well, in general, I think I agree, but maybe give an overview what would be the downsides of employing it in an air-cooled facility. Like just touch on it and that it is a disadvantage to go with lower temperatures, but maybe still give a bit of an overview for the reader who doesn't see it immediately.
yeah, that's a good idea.
Yeah, there's
Steve,
a reason it's not done very, very much, I guess. There is an example in my city in Toronto. Um, but it is, and I guess there are dozens of examples really around the world, but it's not ideal. And actually, one thing I wanted to say when I was on mute there earlier in the introduction there, Gabriel, you were talking about district heating systems in North America. I think, because I've looked quite deeply into about 800 of them. So I know there are at least that many. but probably double that, I want to say. If you count
Mhm.
down to the scale of, say, a campus and a hospital and
Yeah.
that kind of stuff. Still probably, a fraction of what's in Western Europe and Eastern Europe, Scandinavia, but more than you'd think.
For sure. Yeah. We're starting I'll phase this in a second, but I'll throw it in the chat right now. So we're starting a list of potential sites, locations with ideally context if you guys have them, and ideally more than 1 megawatt, because the goal here is to go after bigger locations, bigger sites. But yeah, we're this I'll talk to you in a second once we finish up with the exec summary and stuff. But we're trying to pretty much understand. I think it goes into what Herb was saying, or his comments around, do we include air or not, leaning towards a no. But it's also asking the data operators themselves, like the data center operators themselves, like, would you even consider air when doing heat reuse? And the people that have done it already before. So the goal of these interviews would be to feed into whatever kind of content we're building after the fact, around reference designs, around maturity models, around applications, et cetera, et cetera.
And Steve, before you stop sharing your screen, could you go back to your content or your table of
Yeah, sure.
contents?
I basically kind of lifted it off the last reference designs one.
Oh, and no, I really appreciate you doing all this work. All I wanted to bring up is if we're going to kind of do like some additional, more in-depth cases like what you're started, how much do we want to repeat like business considerations, or do we want to make it really like specific to just this case of what's unique to this particular application? I'm just thinking of like, how people new to OCP find documents and what they read through to avoid repetition and make it unique and build off of other work? Or how do we keep things fresh and up to date? Do we have like a living document somewhere where then these different sections could be amended? Or that's all that I sort of
Mm.
was starting to think about. Um,
I I think we want to make the business considerations a little bit more focused
Compact and focused. Yeah.
than the previous one. I mean, because we reference, in the intro, I referenced the previous one. And I think
Okay.
this one, the business considerations would be, well, or maybe you want to change it from business considerations to stakeholder considerations.
Specific to this topic.
Specific to essentially specific to water.
Yep. Okay.
Going
And I
back to,
mean,
go ahead, I'm sorry.
sorry, I was just going to say that just looking at the stakeholder business considerations for water treatment, anything water and data centers could be it could be a whole book in itself, right? So I guess, yeah, we'll have to see how we tailor that exactly.
So going back to Matt's point, I mean, I think the assumption, it would not be unreasonable to assume that we're talking about new data centers or maybe retrofitted data centers, because these would be specifically designed to maximize heat reuse I mean, one of the challenges that I have is water. So liquid cooled solutions, if you don't know, we have a rack-based technology, which is total immersion with forced convection to cool hot processors. So we combine effectively direct to chip with total immersion, but it's in a rack. So these 2U, 3U chassis in a standard rack. We if it's cooler than 45 C outside, we don't use any water in the server racks. And we have no fans in the server rack. So we eliminate the water consumption completely in the servers and air movement. So the net result is we can produce reliably 60 C waste heat. And so the question then becomes and we're one example, there may be other technologies out there that can do the same thing.
Yeah, Two-Face
So
can do this, can do it
yeah,
too.
so there you go. So why not talk about those applications? Why dumb it down to applications that really don't solve the problem? Why not talk about technologies that are new rather than technologies that are
All right.
tweaked?
Well, I think that's fair enough. I mean, if we're going to come up with a reference design, it's for the future and not for the past or for new installs. I think that's reasonable.
One more comment, then I'll shut up. I mean, the data center industry is under attack because we have so many externalities that affect people, uh, energy rates, water availability. So why not reverse that and create a narrative that says we will solve the water problem, not make it worse? And this is one way to do that.
And I think that's something we can address in the business considerations. Also, the indirect impact on things like permitting and speed of approvals and stuff like that. Community opposition,
Yeah, definitely. That's good to see.
buy-in.
Some examples again would be fantastic of where that's happened. We know that's happening with the grid lines, right? Any data center like allowing some form of flexibility is skipping grid lines, getting permitting a lot faster. So is that the case for heat reuse? I am not aware, but maybe someone can give an example. Or maybe we need to figure it out.
Or we find examples. There's stuff in the press, about data centers are being fought by communities for various reasons. I think most of it's driven by electric costs, but I think there are some that are also driven by water availability. If we're seeing resistance in places like the Southwest or Southern Europe or whatever have you.
Yeah, I've definitely seen examples in Latin America actually of hyperscaler data centers getting stopped because of water problems, like Chile. I think one in Mexico, and a few others. So that's definitely happening.
I think this group should be recommending things that address these problems rather than exacerbate them. I mean, the point simply is that it's a forward-looking document, right? And so trying to make people feel good about what they used to do 50 years ago is irrelevant.
Well, Gabriel, would you want to, put this out here up on the wiki, and whoever wants to could start putting in some edits or comments, and we could start actually moving forward with this?
Yeah, definitely. I was gonna even go a step further and see if we could get some volunteers on specific aspects, just to not have you do all the heavy work. So Anya, you brought in a great idea around the energy costs and not just the cost, but the actual energy requirements of things like water treatment, desal. Do you think you'd be able to do a little research into what that looks like generally?
Sure, I could try. I might ask for help if I have
Of
trouble
course,
finding anything,
yes.
but I think this is data that should be available at least for some countries, like the European Union and the US
Yeah.
probably, and Canada.
Yeah, anywhere we can start,
Yeah,
just a
sure.
little baseline. That'd be fantastic. Thanks so much. Um, Around the maybe stakeholders, does anyone want to take a swing at it? Put some thoughts in. It can be bullet points at first, and then we can, uh, use a bit of AI on it and kind of work it out a little more.
Yeah, excuse me. I don't
I
know.
we got two mats in here.
The other mic was supposed to be off. That's better. Yeah, this subject, although super interesting to me, is a little outside of my wheelhouse. I've done a little um, AI research on it, as you say, in the past, looking at it, and the one thing that um, stumped me that I I'm not sure if is addressed in here is just the different technologies for freshwater production, like the different desal technologies. So the heat reuse isn't really um, well suited for all of them. It's better suited certainly for a couple specific types. Is that in here?
Well, the main competitor to this is membrane distillation. And I found some stuff on who the leaders are on that. And the one leader is going out of business in July.
Oh shit.
And
Oh,
I
really?
and I think and part of the problem is that the fact that membrane is essentially use the heat once, whereas multiple effect is particularly if you're starting to have higher temperatures to work with, you can reuse the heat several times with evaporation. And that's just so you get more water for your buck, if you will. But I
Hmm.
mean, from a business considerations point of view, I think it's just a matter we need, someone to take a swipe at, what the water takers, if you will, are thinking about, as well as what the water consumers on the data center side and the community side are concerned about.
Yeah, definitely. And even I would go one step further and if we're able to rule out, specific types of technologies, like Herb was saying with air, just as, not cost efficient, or certain geographies, like Steve, you were mentioning earlier, like maybe we should focus on specific areas of the world where, energy is expensive, desal or water treatment is necessary, and it's in short supply, and there's data centers. And I think the more targeted we are around these things, and we can present that in this paper, the more it's going to be helpful for the industry.
I agree with that. I mean, I think the goal here should be to help people make decisions rather than just lay out everything and let them go do what they have to do. I mean, we can guide them as to what makes more sense than some of the other options. What makes the most sense?
Awesome. Alrighty. So I won't put anyone else on the spot right now, but if we could have a think about it, and a few more volunteers to help Steve here. Of course, don't need to be full on experts necessarily, but just adding your ideas and how we should frame this, what we talk about specifically, what you think will be useful for the market. That'd be very, very helpful.
Are you going to or sorry, will this document be shared as a uh, Google Doc or something?
Yeah,
I
so I'll
did
throw it on the. Sorry, Steve.
I did it in Word because that's what I'm used to using, and I know from some of the other groups that trying to work and go back and forth between Google Docs and Word can be difficult in terms of formatting and whatnot. So if we have a subgroup that I can work with together, maybe we'll just stay within you know the Word doc, and then when we're finished, we could push it out to more generically or as a PDF or whatever have you. Is that
Yeah, I
reasonable?
have Word. I'm happy to join as an editor and put some time and thought into this.
Thank you, Matt. Steve, would it
Herbie,
be okay if you sent it to me and I put it up as on the drive, and that way we can all see it and have the same
yeah,
same
you
version
already
without.
have it.
Oh,
It should
of
it should
course.
have it should have been attached in that email I sent.
Right. Yep. 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 100%. So I'll do that, and I'll share with those who are interested. Matt, I don't know if I have your email.
I've got a new
There you
email
go.
here. I'm trying to de-Google my life a little bit, so I've just tested it in.
Beauty. Awesome. Anyone else interested in, if you don't mind throwing your email there, and
Tell me more about
I'll
what's
share
on your mind.
this right after.
I do.
Herb, you going to join the party?
I do still have a Google account and Gmail if it turns into a Google Doc, so that's fine too.
Yeah,
But
that's
better.
kind of where we still work with OCP. So if you don't mind, despite the de-googling, we'll bring you back a little bit.
Yeah, that one might still be on file somewhere, but it's here. I'll just type it into.
Awesome. All right. So I'll transition to the other side. So as mentioned, we're kind of working on two major things here from the reference design perspective. The second is, I'd say, maybe taking a step back around what is the objective with not just the work stream reference designs more specifically, but obviously we want to try to increase the uptake of heat reuse. I think everyone can agree with that here. And there are a plethora, even like you could say a good amount of heat reuse projects that exist out there, some bigger than others, of course, but growing quantity with different kinds of applications, most of them focusing on the low-hanging fruit, which is connection to district heating, greenhouses, pools, et cetera, et cetera. But in talking with David, we decided that would be a good idea to kind of go through the motions, sit down with some of these stakeholders that kind of drove these projects. I mean, all of you are aware that whoever wants to deploy heat reuse today still needs to be quite set on it, right? Like there's going to be hurdles, and they need to find a way to get through them. Since on our side, we don't have too much visibility on like what these specific hurdles in each application are. The idea here is to do some form of like interviewing throughout this year in preparation for the global summit in October. And then we would present our findings, as well as, in whatever way we can, also give more information on our learnings to these stakeholders that we interview throughout the year. So that's the kind of background. So far, the idea is that we're preparing that list I sent in the chat. So if you do have ideas of like companies, sites, people that have deployed heat reuse and are willing to talk about it, please throw them in there or send me an email. Either one works. And then I just, started maybe drafting up some questions. Nothing crazy, but wanted to get your guys' eyes on it and see if it makes sense, if I'm covering the right topics, if you feel like we need to go into more technical detail in some aspects. It's very, very general right now, and I'll share them. But
Would you mind sharing that list again? I switched devices and it's not showing up in the chat history.
Of course, let me do that first.
While you're doing that, it might help to think of data centers and heat reuse as an infrastructure project and more than a simple data center project. It's part of a project that's bigger than just data centers. And the off-taker might be any company, any operation that needs hot water year-round. Could be desalination, of course, but there could be food processing facilities. They don't necessarily need to have data processing needs, but they need to have hot water. And you could locate the data center nearby, assuming it's new. There's an explosion of data center construction anyway. And so rather than look for places where there's water to use for cooling, you could look for places where there's water that needs heating.
Yeah, that's a great point. I think yeah, it could definitely be um, data center operators that exist already, and or the flip side, the district heating that is trying to fit that to data centers. I was kind of thinking of it from a data center perspective, just because on the OCP side, that's kind of where our background comes from. But if we find a way of interviewing people on the other side and thinking of it more as infrastructure than just data centers, then I think that's fantastic. Feel free to add to the list if you have any examples.
Real, there's a scenario that could be used as a lesson learned. So George Mason University is in the Nova region of Virginia and
Mm-hmm.
has a data center, maybe a football field away from them, adjacent to their athletics facility. So they got two boilers, they're heating a pool, they're heating the facility, and the regulators asked if that location would be a great pilot project. So there isn't any regulation forcing this down their throat. There is no incentive money that's incentivizing them to pursue this, but they know where everyone wants to go with this. So they initiated some early discussions with maybe a Danish company or a few others that are practicing this well because it's regulated and they're expected to deliver a heat ready, heat reuse system in their data centers. So when they brought that here, they realized that it wouldn't financially pencil. And
Mm.
I think it's important for folks to understand, well, then what is that gap? Because if we did all this design work, even back to the napkin work, and we factored in all these great design options that you just saw on the screen earlier, but none of them pencil, well, what would it require to pencil? An additional incentive? Do we regulate that
Yeah,
incentive? Things like that. So I know there's a separate regulatory policy group, but the implication here is,
it's all related. Yeah.
yeah, and it's been designed. So what is the cost to design it? What is the cost to construct it? What is the cost to operate it? And in those three areas, what was the hurdle that prevented it from happening? Was it the design?
Mm-hmm.
No. Was it the construction? Maybe, because it had an impact on the data center operations. It had an impact on the academic use of the facility. But the operations and maintenance side of it was where they definitely pushed back, saying, we have a hard enough time with SLAs for folks trying to service our water side of our systems. And now you're going to tap into ours and create more risk. How are you going to mitigate that? You have a hard enough time managing your own higher ed facilities. You have a significant deferred maintenance budget. Why would we sign up for you to be a partner to our facility if you already have so much risk? We're not in the same risk profile world. So those are the more complicated, maybe even legal discussions that start coming out of this, but it's still important for folks to see the whole life cycle of this, how it's played out, and maybe that starts the pilot discussion.
Yeah.
The other thing is somebody asked, is air going away? Air is never going to go away because we still have transformers and PDUs and all these other systems that
Storage.
don't have a cold plate on them. So unless you put a cold plate or tubing through transformers and PDUs and everything else, then maybe you have a full liquid cool facility, but you're always going to have, the air crack units. You're always going to have fan cool units, air handling units. And there's a balance between how you figure out whether you pick up the primary side of that, which is a blend of technical water systems where you're doing liquid to chip, and the balance of these air-cooled systems that are bringing that heat back with coils. So if each site has a unique primary chilled water system or primary condenser water system, and those temperatures would need to be understood to then figure out how you can reject that heat to a local consumer or off-taker. So just want to throw those two in there because they have a major influence on how you move forward.
Why do you think they'll always be air cooled? Even, I mean, direct to chip has air cooling, of course, because only 70% of the heat's removed by the liquid, so you still need to move the rest of the heat. But there are technologies that don't require air at all, at least at the server level.
We have to take a step back and look at the entire facility. Um, we may grow in the number of pieces of equipment that receive liquid cooling in the future, but air cooling of the facility will never go away.
I disagree with that.
We still need
Sorry,
ventilation.
guys.
We could have this off different.
Yeah,
Yeah.
Yeah, but
that'd be
just so
appreciated.
you know, the bigger players from the bottom, from like the next 5 to 7 years of designs and the forecasts, you asked the question of whether they were going to still be air cooled. Yes, all of the forecasts for the
I know.
designs that are in play are still air cooled.
Yeah, those, but they're not. I mean, that's what Kodak said, and that's what Xerox said. And where are they today? That's not worth. Anyway, we could have this conversation offline, maybe.
Well, but that does bring up the question, what time horizon should we be thinking about for this group? Should we be
Right.
thinking in the 5 to 7 year scale, or should we be thinking in the 20 to, the 20+ year scale?
Near
I
term.
think for OCP to be meaningful, or for us to be meaningful to the OCP stakeholders and members, I think, you know, a shorter time scale, which for them is still long term. I mean, folks that are building data centers on an 18 to 24 month schedule, to them 5 years, 7 years out is, oh my God, that's 3 generations in the future.
Right.
I think you answer the question. You can't look that far out because
Right.
only district energy players want to look at a long-term deal. Some of them that are being asked for these 2 to 3 and 3 to 5 and 5 to 7 year deals are more interested because that's where they know they can control technology change. But we have customers that are flipping out these boards every 2 to 3 years, and the heat rates are going up on these racks. So we're going to hit a limit. No one knows what that's going to be. And the question is, do we change to a different phase or immersion or whatever that is? But the balance of those things that aren't touching the liquid are still going to require the air cooling. So again, yeah, you're right. Maybe there's some future goal where every transformer and switchgear has some sort of cooling media that's going through it to remove the heat. But in the perfect world scenario, that's the case. Currently, there's still so much pressure around just getting fundamental equipment out over the next 5 to 7 years, getting these factories to produce it. That design change would have a major influence on supply chain. So that's the hurdle we have to work against, of just really having the ability to build these things and meet the demand for the market.
Yeah, I think there's so many ways to differentiate, what I guess how this world is structured on the off-taker side and also on the data center side. Like, are we talking about retrofits? Are we talking about new construction? Are we talking about, smaller deployments, near edge stuff? Are we talking, in the sort of single digit megawatt range, or hyperscaler stuff? Like, the motivation to build a large facility or retrofit a large facility is never ever going to be anywhere close to what the needs of a heat off taker are, if you even possibly, if there's even the remote chance that there's one nearby. So it doesn't, this scenario doesn't really fit everything perfectly. There's, I think, only certain types that are even worth considering. And then, lining them up with industry, but it's it's a challenging matchmaking exercise. You certainly can't turn every data center, existing or new, into a heat reuse facility, because it's just not even really on the radar for site selection and PPAs and whatever, you know.
That's true.
Yeah, that sounded pretty defeatist.
Well, it's true, but there's so many data centers being built from scratch right now. Doesn't it make sense to focus on them rather than the ones that have been out there for a while?
Yeah.
Because the new ones could be built for around new technologies.
Yeah.
Or they're more easily adapted to new technologies because they haven't been built yet.
And there's a segment of, sovereign compute, sovereign AI, high performance compute stuff that's moving, back away from the centralized formats
That's the other point, right? Exactly.
to the edge, which generally means closer to urban, suburban centers where heat is actually needed. And so, those are the scenarios, I think, where it's kind of perfect, and where it makes sense from a project perspective as a data center developer. One thing you maybe don't care about is like selling your heat or entering an SLA and selling your heat for, whatever, pennies on the dollar, of your energy cost. But what you do care about is like deploying faster. And if you can get, faster permitting because there's power capacity that's already earmarked for heating, electrification of heating, that's something where suddenly, people are listening, right? It only makes sense.
Hmm. Yeah, 100%. And that's kind of the goal of what we're trying to get with these interviews too, is to, it's research in the end. We're trying to get a good data set that tells us whether our intuition here is correct with all these comments. And then ideally for me and hopefully for all of you guys too, we kind of get that we draw that line in the sand of saying like, you know, over this line, like with Herb's example, maybe air cooling is just not worth looking at heat reuse. And just, if you're doing air cooling, don't look at heat reuse is kind of the our best advice. But then when it comes to liquid cooling, when it comes to um, you know, you're in an edge deployment near an urban center, you have to be making some sort of heat reuse exhaust pipe escape, um, that even if you don't think about heat reuse right from the first construction, at least you have that option to connect to an off taker down the road. And then if we can build that out per different types of applications, including things like the desalination, water treatment, I think that could be future projects and future work that we kind of get out of this first one, if that makes sense.
I think a good question to add to this list is who paid for it.
Yeah.
Was there outside were the CapEx costs split in some way, or were they, funded through government grants, that kind of stuff? Because that happens a lot. And then you probably have it here in some other form that I just missed, but essentially like why? What was the main motivation behind this project being done? I assume this is not people
Yeah.
who are interested in general. This is people who have done it. Um, Either on the data center side or the off-taker side.
Yeah. Yeah.
Or
Yeah.
So
tried
yeah, like
and failed.
The
tried and
mo
failed is great too. Yeah. Even better actually sometimes. And then added this section, which I, like in writing it out, I thought it was great. And, always great to hear from new people that come on board and say, look, love the wiki, love what you guys have up there. So um, I think this can be two-way, right? Like we can, in my email drafts that I'll send out to the people that we choose, I'll make sure that's clear. Like we want to hear from you, but also how can we help? Did you even know about the wiki? Because that's also good to know if people are reading it or using it as reference. Um, so yeah, I'll share this as well. I don't know if anyone has any other comments now, or yeah, have a think about it.
Have you got a sense of like how many people kind of like to interview, and also like who's going to kind of interview them? Are you kind of like having sort of trying to have the same people be in the interview
Yeah,
process if you get some people that are willing to do this?
yeah. So I think we can have a mix of people. Like sometimes I think it'd be fine if someone has a good contact, they have a good relationship with, and they would like to do it and kind of follow the same questions to make sure that the answers are comparable. I think that's
Consistency.
absolutely fine.
Hmm.
Exactly. Um, it'd be great to, of course, have you on a lot of the calls and to ask the questions. And I think one of the people on the list is you too. So we'll
Oh,
be
well,
throwing the
and also I
questions
think we had
your
talked
way.
about representatives from the other working streams, or whatever we refer to them as, the
Yeah,
finance and the policy.
Would
Okay.
these
yeah, for sure.
interviews be would the interviews be recorded and transcribed? And then we could maybe use some of the AI tools to see how they line up with the various interviewees to see if there's commonalities, whatever have you. I make it just a little
If
easier
they're
for
willing.
mechanics putting together a report.
Yeah, yeah. I mean, I'd be open to that, of course, but we'll have to see if the people getting interviewed would also be okay with that. But it's an idea, yeah.
Or if they want it anonymized, yeah, and whether or not OCP
Yeah,
has rules around some of this stuff too. When you start interviewing.
True.
Yeah. Okay.
True. Yeah. So on the number side, David, you asked too, how many do we have on the list and stuff? With that project list, database, and all the ideas people have been adding, I think we're gonna have quite a lot, at least for the initial outreach.
Okay.
Of course, if anyone has low hanging fruit, I think, sorry, I couldn't see who was talking, but the example of the university trying to connect with the two boilers, that's the kind of example that like it'd be great to talk to these guys and see, like, dive into the details of like why it didn't work. Okay, that cost gap, um what could have helped in that specific scenario, what kind of grant or help from an outsider that could also be interested in having that work, et cetera, et cetera. That sounds like a great case study. All right, so let's wrap it up around here. Please, if you have comments, review the two docs, add your thoughts in there if you can, or feel free to email me. I'll resend my email because I sent it wrong the first time around, which is not very helpful. I got a few emails, people telling me it didn't work. So I just added one P too many. So that's the email there. So yeah, feel free to send me some of your thoughts around these two documents, and otherwise, we'll see you again next time.
Sounds good.
Hey, thank you.
Thank
Bye.
you.
Thanks.